question that says, where do ultra-high energy particles come from?
Yeah. Okay, so ultra-high energy particles are, what we're talking about here is like really small particles, like the nucleus of a very simple atom, like perhaps a helium nucleus or a hydrogen nucleus, being fired at a very high speed. These things typically get up to like the speed of light. And the truth is that we don't know exactly where ultra-high energy particles come from. Another name for ultra-high energy particles is cosmic rays. So it's been observed that equipment that goes out beyond Earth's atmosphere, beyond Earth's magnetic field, or astronauts that have to go out beyond Earth's magnetic field, like say go to the moon, experience a degree of radiation higher than people that live on the Earth. Thanks to Earth's magnetic field, cosmic rays that are all around us in the universe, 99.9% of them are actually blocked from arriving onto the surface of the Earth, thanks to Earth's magnetic field. But if it weren't for that, we would be exposed all the time to these really, again, high energy particles that are, again, just these small particles that are being shot really, really fast. And the concern there is that being exposed to ultra high energy particles like that over long periods of time can increase the risk of fatal cancers. For example, maybe if we jump to my screen really quickly, I'll just show a quick image here. So one place that we know high energy particles come from is the sun, although solar high energy particles are not as high energy as other cosmic rays that we've seen. So we know that stars like the sun are capable of jettisoning off high energy particles that certainly can cause damage to living organisms that aren't protected by a terrestrial magnetic field. And you can see in this drawing just sort of this simple diagram, the blue lines surrounding this ball here represent Earth's magnetic field, and you can see that they effectively block or deflect most solar energy particles that come at us from the sun. But again, it's been observed, there was a time when scientists thought that the best explanation for where ultra-high energy particles come from would be supernovas. So supernova is the explosion of a very large star. If that were the case, we would expect that cosmic rays, or these high energy particles, would come from specific locations in the universe. Like we would see concentrations of them in different places, and we would expect high concentrations of them in areas where there had recently been supernovas. But when we look around and try to observe for high energy particles, what scientists find is that cosmic rays like this come at us from all different parts of the universe in seemingly equal concentration. So there's not one particular area where we're receiving more cosmic rays than another. So that creates this really interesting question of where could these things be coming from, and what could be producing cosmic rays on a scale that they travel sort of uniformly around us in the universe. But again, so we don't really know where they come from. We think that they likely come from very intense star activity. There may be interactions with other space objects that you might find, like nebulae or black holes. But ultimately what we're talking about here is just the nucleus of an atom being shot at super high speeds. And just as a last wrap up, we're getting closer and closer to talking about sending humans to Mars and perhaps beyond. I think it's likely that within my lifetime there will be one, if not more, missions to Mars. There's certainly one planned within the next decade. And when we talk about sending people to Mars, we talk about having human beings out exposed to cosmic rays for long periods of time. And there's this measurement scale called the Sievert scale that talks about how much radiation a person can be exposed to safely. So they say that if you're exposed to like 1 sievert of radiation, you have an increased chance of getting cancer, and that increased chance is about an increase of 5% that you're going to have a deadly cancer. We here on Earth experience like 0.00001 sievert in a given day. Again, because our magnetic field, the magnetic field of our planet, blocks us from cosmic rays. But a person who is traveling even at the shortest distance to Mars and back, the quickest possible trip, would be exposed to at least a half sievert. So that would be like an increase of 2.5% chance that they would contract or develop a deadly cancer. And so you can imagine this compounds, if we talk about having people live for long periods of time outside of Earth's atmosphere and magnetic field. So, we talk about sometimes putting people on the moon, people living on the moon, or people living on Mars. And if you have a person that's exposed to cosmic rays for long periods of time, the chances that they're going to develop deadly cancers really increases. And so that brings up the idea that if we are going to have people live in space in the future, we're going to have to think about creating living spaces that are protected from cosmic rays, perhaps that are buried underground. So anyways, just a little side note there.
Interesting to think about
Indeed.
how that'll go.